Process of neurotransmission. When zooming into the brain, neural activity can be identified. Electrical signals travel from the dendrites through the cell body, down the axon, and then arrive at the axon terminal, where a process called neurotransmission takes place. But first, action potential propagation. If we further take a closer look at the axon of the neuron, the electrical message or action potential can be seen travelling down the axon towards the axon terminal. Positively charged sodium ions are situated along the outside of the axon, and negatively charged potassium ions are situated along the inside. Pumps allow 3 sodium ions to travel into the neuron and also allow 2 potassium ions to travel out. This depolarizes the neuron. What have you just learned? 1. The electrical message or action potential travels down the axon to the axon terminal. 2. Positively charged sodium ions and some positively charged potassium ions are situated along the outside of the neural membrane in the nodes of Ranvier, and negatively charged potassium ions are situated along the inside of the neural membrane. This forms a polarized neuron or a resting neuron. The polarized neuron sits at a voltage of negative 70 millivolts. 3. When an electrical signal passes through the axon, this triggers 3 sodium ions to move into the axon for every 2 potassium ions put out. Pumps, located at the nodes of Ranvier, use energy to move the ions in and out of the axon, depolarizing the neuron and increasing the voltage to negative 55 millivolts. Only once this voltage has been reached will the neuron then fire the action potential down the axon. Once the electrical message has passed, the neuron begins to repolarize through a reverse process. Neurotransmission. What have you just observed? Mitochondria, yellow, produce energy that drives the production of vesicles, green, and the neurotransmitters located within the vesicles. As the action potential reaches the axon terminal, specific vesicles holding specific neurotransmitters are triggered and begin to fuse with the presynaptic neural membrane, and the neurotransmitters are then released from the vesicles into the synaptic cleft. The neurotransmitters then swim through the synaptic cleft to the postsynaptic neural membrane, where they latch onto specific receptor sites. Only when the neurotransmitters have binded to their receptor site will the receptor or ion channel open. Once open, charged ion particles are activated, which allow change in electrical properties of the membrane. The most common charged ion particles are sodium, potassium, chloride, and calcium. With the now small electrical signal or synaptic potential produced by the charged ion particles, the postsynaptic neuron will fire an action potential, but only when the sum of all the synaptic potentials is the same as or exceeds its threshold. Let's take another look. Vesicles holding neurotransmitters are activated and begin to fuse with the presynaptic membrane. The neurotransmitters are released into the synaptic cleft and then latch onto receptors located on the postsynaptic neuron. Ion channels open and activate the charged ion particles, which change the electrical properties inside the postsynaptic membrane, overall triggering an action potential to be fired. Produced by Jack Elliott, Rachel Tien, and Tien. Bibliography.